Do you need to share yours?
No, you're good.
All right, here we go. Hi, everybody. Welcome. My name's Chris Little, and this is Blair Suley.
Hi, everybody.
And we are at the Trihedral offices in Bedford, Nova Scotia today. And today we'd like to welcome you to our presentation entitled The 5 Most Common Topics at ACE 2015. Some of you were able to visit us, but for the majority of you, this was, I assume, your way of catching up and getting a rundown of all the most important SCADA news in one place. So thank you and welcome. Before we begin, I just want to run through a few of the usual webinar housekeeping items. And the first one is on your screen on the right-hand side along here. There should be a menu of items. And at the bottom of it, there should be a little box called Chat. So throughout the presentation, we're going to be covering a lot of territory, particularly Blair. And if you have a question at any point or something's not entirely clear, please feel free to type in a question there and hit enter. And what I'll be doing, I'm going to be the co-pilot for most of this thing. So I'm going to be scanning the list of questions and then feeding them to Blair as, I have to share the webcam. Can everyone see me? Let's go to the attendee list. Now, if you go to your little menu on the right-hand side, you should see a place where you have a little hand next to your name under attendees. Can you just go to that, and if you can see me, click your little hand.
Interesting.
Webcam is on now. Okay, sorry. I'm just checking my back channel. It was Natasha on the other end who was reporting that the camera wasn't on. So, can everyone see me? If you can't see me, click on your little hand. Let's try that. Oh,
is it now turned off?
Oh, now it got turned off.
Okay, people can see you.
Now,
there you go.
There we go. Excellent. Technology is our friend. So here we go. So if you have any questions, type them in the chat box. I'll feed them to Blair as we go, as it seems appropriate. If you don't hear it right away, for sure we'll get to it by the end of the webinar. So that should be it. And now we're just going to get started. Hit the first slide here. So this is us at ACE 2015. Because you'll notice a few years ago we switched to a new booth. It's a much larger booth, and it has a big awning on top that actually says the word SCADA. And in the skyline of the ACE show, or even at WEFTEC, I think we're pretty much the only one who fly that kind of flag that specifically says SCADA. So when people have a SCADA-related question, or they've got something they really need to share, they look up, they see that, they think, well, I'm going to go and tell those people about it, or I'm going to ask them. So we're in a kind of a fortunate position to be the aggregator of all these questions and all this interest. So today we're just going to share that with you, and Blair's going to do most of the heavy lifting. Take it away.
Thank you. Thanks, Chris. Our focus is going to be on the SCADA software side, which obviously is the area that we focus. We've had a lot of people come to us during the show, a lot of great questions. So we started off with the idea of the 5 most common questions. What it turned into is the 5 most common topics. So we really have areas of questions, and we're going to try to formulate those into a discussion. Chris and I are going to keep this relatively informal, try to keep the discussion loose. You want to participate, please, as Chris mentioned, throw in your questions. We'd love to have a chance to answer them. Here's our agenda. We're going to keep it really simple. The industry direction itself, where we are going, and this is largely based not only on what we know from being in the industry, but also kind of a summary of what we heard while at the ACE show in particular. 5 most common topics from ACE 2015 with respect to SCADA software in particular, and the lessons that we kind of learned from speaking with all these people. Now keep in mind that this show, held in Anaheim, was obviously very influenced by the California market and the Southwest market as well. So it may be somewhat of a different take than you hear in other areas, but we'll give our best shot of being able to present that. So where's the industry trending at this point? There are three major areas where the industry is focused. One is on maintenance, the other one's operations, and the third one is planning. Right in the center of all those in this Venn diagram here is efficiency. Everything here we talk about is about efficiency. That's all we heard when we came. That specific word may not have been said, but everything we heard was based on that. Reducing response time, changing and rolling out integration, doing it quickly while minimizing your downtime. Upgrades, how do I do upgrades without incurring big downtime? How do I, and this is really one of the focal points for sure, is how do I make more informed decisions about my SCADA system and therefore changing my operations, making me more, not me, but making the utility more efficient? How do I reduce my cost? And of course, how do I reduce the waste? Every road we traveled down in California had a sign of some sort that indicated they were in drought, as we all know. So minimized waste was the topic of the week for sure. And that said, let's head to the first question. I was kind of surprised that there were so many utilities that referred to not having anything installed or having a legacy system and having to move forward. I'm not surprised so much about the legacy system, but I was surprised so many did not have a direction at all that they had followed within the SCADA software world. So let's look at building for today and planning for tomorrow. Every utility's expectations are different. I've kind of summarized these two general set of expectations here. First one, I have nothing and need SCADA, and what do I need? Relatively common question. We probably had 3 or 4 groups who came and knew very little about SCADA, but were really interested because they realized now's the time, I got to jump into this, where do I get started? It gives them an advantage over those who do, in that they can standardize and select whatever components that they like right out of the gate. We all don't have that same capability. And even if they do have a large capital budget, let's keep the plans within reason. Plan for progressive build with adjustment periods. The idea of change management is such that you apply some change, you let things settle, and then you apply a different change. Let your people get used to the change you've implemented before you apply new change. The other question, I have a well-established legacy system. It's too expensive to change. This was also rather common. And my suggestion is, what are the next 5 years legacy software support costs versus the cost to migrate? Okay, so your legacy support costs, if it is in fact a legacy system, it's probably not well supported. And if it's not, you could be incurring very large annual fees to maintain. Therefore, what's the cost to migrate and its fees, and is that significantly better? Secondly, software is the keystone. It's the glue that's tying all the other pieces together. It's the one that your operations, that your maintenance, that your management need in order to see the status of everything. So if you can change that one keystone, that will give you the next ability to do a flexible, scalable, open platform and then plan for your next level of change. Maybe that's your security, maybe it's your controls, maybe it's some other piece of it. So the whole idea is about a well-organized migration path. Let's look at the first steps here. First, you want to define the goals. I want SCADA is not a goal. Okay, I want a SCADA system so I can reduce my time that my operations team has to spend in the field. That's a goal. I want to reduce wasted water, or non-revenue water. That's a goal. Okay. Take inventory. Look at all the things that you currently have installed. If you have nothing, you don't have a whole lot of inventory to take. If you have some stuff installed, you've got your controls, your communications, your computer software, security, and then evaluate each of these components. Look at the components themselves and say to yourself, what are the risks associated with that? I'll give you a few examples. Windows XP is a risk. It has security associated with it. You really want to move to the next step of Windows. Security that does not apply appropriate encryption for remote end users. Okay, that gives you a risk that you really should attack right off the bat. You may be looking at network and limited bandwidth on communications. Okay, you might not have drive space in your computers. There's all kinds of risks that you can address. So you really have to define which of those has the reasonable priority to go after to start with. So prioritize each one and then create a rollout plan to match the resources that you have. You're going to be limited in these 3 resources.
I was also impressed this time around how many people approached us either with very defined goals or we're talking about master plans.
Yeah, there was a lot of people. We've heard about master plans a fair bit lately. It's not new, but it is something that's become much more common, and there are a lot of consultants that are focusing on master plans, particularly in the California area. So a lot of access there. So I think that's why we saw so many utilities coming to us with the idea of master plans.
By the way, I figured out how to turn off the bloops. So
the bloops?
Yeah, the machine was blooping. Bloop.
Gotcha.
So you can all relax. Sorry, carry
on. Open architecture and open source. I want to address these 2 things. Open architecture is really about allowing software that allows easy integration of a variety of components, whether those components be security, communications links, controllers, and from the other side, the data communications and the ability to extract data and use it in third-party systems. Okay, you want to adopt a open architecture, a flexible platform that gives you the ability to utilize some of this flexibility to change and migrate over time away from whatever your legacy pieces might be, or for that matter, whatever controller might be that's not giving you what you want at this point, maybe too expensive, for example. Open source, completely different thing. What open source is a software licensing methodology. It's freely used, shared, and modified. Okay, and there's a caution associated with that, and that is that it may be subject to, I've got diverging functionality paths, meaning one utility wants to do something, they have someone develop a certain set of functionality, another utility wants to do something else, they develop a different set of functionality. It's not just utilities that address open source software. It could be anyone who has functionality they want to build into the system. That functionality becomes available to you. The problem with that is that that functionality then affects you. If that company that made that change goes out of business, the functionality is essentially not supported by them. It's supported by whoever is out there and has it.
So that's an important distinction. VTScada, for example, is open architecture, but not open source.
That's correct, yeah. The open source licensing may also affect you as well, in that if you include open source functionality, open source software within your system, you may be required by law, by the licensing agreement, to make the functionality that you've included available for all other users. That can be a whole other licensing thing that you may or may not want to get involved in.
Oh, while we're pausing there was a question. Somebody asked, what does ACE stand for? And I apologize. I was assuming that everyone sort of came to this from our emails coming out of the trade show. ACE is the AWWA's annual conference and exhibition, which just wrapped up in Anaheim a few weeks ago. So yes, we were there with our trade show booth.
And AWWA is?
The American Wastewater Association.
Yeah, exactly. Waterworks.
Waterworks, exactly. Correct, Blair.
Keeping the check in check. As a final piece of this is the costs associated with SCADA, the real costs of maintaining the SCADA software. We all think of the software itself as being just the software, but it has an effect on everything surrounding it that makes up the network. And we're talking the SCADA licensing itself, the upgrades, computer licenses, computer hardware, operating system licenses, networks, security appliances. There's all of these different parts that have to do with it. So if there are ways to improve the efficiency of your whole system, you can reduce the costs of a lot of these components. What we do as VTScada, we make a very efficient platform. The idea being that by doing that, you can roll out larger systems that have less requirements for resources. And I'll just show you an example of one that we developed when we first proposed quite a number of years ago. The City of Sacramento, which I actually spelled incorrectly. That's interesting. Okay, Department of Utilities, City of Sacramento, SCADA. They eventually adopted VTScada. We're now their platform of choice. If you look at the various plants that are here, this is what was originally planned for the system. And what you'll see is that we have scratched out the need for this, scratched out the need for that. Site servers, intake server, removed. The reason is that we didn't need these. A lot of the hardware that was there was left over from their original design that they had from the previous SCADA software vendor, and we were able to remove all these. As a result, they had less expensive server computers. They had no need for dedicated historians or I/O server computers. All this functionality was now built into the main servers, and along with that goes the operating systems that you would have had to pay for. And you have less networked computers, less network connections, and simpler security management. So all those things affect your costing in the long run. And when I say the long run, you're not just putting in the money up front to put these things in, but you're also putting the money in on an annual basis to maintain, to configure, to update these things.
Mark, you're welcome. And yes, we just so everybody knows, we'll be putting this presentation on our website to download after we're finished.
So let's look at topic number 2, standardization. We had a lot of utilities come in asking about multi-plant growth, the ability to put in one plant or migrate one plant, but then also being able to migrate all of their others and come across with a common theme. Well, we're going to look at scalability in a bit, but the key and core functionality of scalability is in standardization. Standardize on the labels and color meanings. So you want to look at across the board, where can you come up with something that's very common, that everyone will understand, and that regardless where they end up within your organization, they're going to immediately recognize what that color means, okay, what that label means. I think we do a system for the Niagara plant group in the power industry, and they have a very concise yet comprehensive understanding of what all of their colors are, how things are labeled, what exactly the shape of each and every item on every screen looks like. Okay? They've defined that well, and they've utilized that across all their plants. Now anybody can go to any of their plants, and they have many, in which case they know exactly where they are and how to look at that SCADA system without individual training on it. I'll look at that in a minute. So just to give you an example here, we've got color meanings. Red can mean hot, it could mean off, it could mean alarm. There's a variety of things that red can be used for. Okay, so you just got to standardize on what that means. Developing data structures, graphic layouts, and menu flow around the common use case scenarios. And when I say use case, what I mean is, how do the operations teams, how does the management team, how does the maintenance team, anyone who touches the SCADA system, how do they use the system? How do they want to use it? They may use it differently than they want to use it. So define that. Get that set first, and then create things around that that make sense. And finally, create a reusable data and graphic template architecture that you can reuse to scale your system up. So give you an example of how we implement that. Here's an application, the one that we were showing at ACE. And if I look at this is our development studio here. If I look at these templates, what these are complex templates that define a lot of variables in one graphic. They are a template. I can reuse this again and again. Here's a station details template. Okay, see there a ton of data that's represented on that screen. I've got faults, I've got inputs, statistics, summary information. I've got my controls, I got my well information. Now that's a very complex template, but what it does is it greatly enhances my ability to stay standardized and be consistent across all my wells. Now I'm not limited to that either. Go back here, not everything can be standardized. We may have to adapt what we have. Rigid enforcement of rules can hinder the future supportability, which brings me to another utility that came up at the show, and their problem was they were mired in the muck. They really had come up with a concept and a standardization technique that had really worked well when they first started putting in their system. Now they find it very hard to make changes because they've been so rigid in what they've allowed people to put in. New integration teams come in, what they've allowed them to do, adhere to what we've previously done, adhere to what we've previously done. The end result is that they don't have the ability to be flexible and to make change where they need to expand. I'm going to show you here high performance HMI techniques. Are they good or are they bad? Essentially, they're good. If you look at the concepts of high performance HMI, which is a new concepts set that has been promoted within the SCADA industry, in the SCADA software industry, the idea is about easy recognition of issues, anomalous conditions, focusing on standardization, decluttering, and what we really want to do there is be able to apply those techniques, but we want to be able to apply them within reason, because we've got it's really designed for continuous process with little variability. But some of the ideas work really well. If you look at the concept of I use color sparingly and only really to recognize issues within the system.
So screens are dull until something bad happens and then they become interesting.
That's a nice way of saying it, yes. So if I look back here and I've got 4 different dashboards, well, these are really sales-based dashboards and they're meant to sell the product. They do a good job at that, but they aren't really reasonable in that they're so different and expressive and colorful that they don't really give good information. What they give is a lot of great looking graphics. Okay. If you were to do it for the high performance HMI concept, what you'd have is much more dulled colors, much more dulled graphics, and only those things which should represent anomalies stick out at you. So it's up to you what level of that functionality you want to accept.
Plus, it's premised on, do you actually have people who spend their whole days staring at screens? For a lot of utilities, that's not a reality anymore. Now they have people who are actually out in the field doing things, and when something goes wrong, you want your alarm notification system to track you down and tell you about it wherever you are, which is a slightly different model than what you were talking about there.
Actually, very different. The concept that we were referring to, the idea of sitting in front of a screen, still done in a lot of industrial plants. Not typically done in the water wastewater industry. Not done in a lot of industries that have active operations now that are in the field or functional. May not necessarily be as many people working for a utility or for an organization as there were previously. The benefits of continuity, I already mentioned a couple of ideas. Really, it's about the simplified training for onboarding employees. Your existing employees, they know where everything is within your system. Your new employees, and there will be a movement of employees over time, they come in, you want them to be able to quickly get up to speed. You also want them to minimize the confusion. All the confusion that surrounds high stress situations, something bad is happening in your plant. You've got to address it right now. Your easiest way to do that is to minimize that functionality within the HMI that is going to potentially confuse them. Okay? And then we also have the ability to simplify deployment to new assets. Pump N looks like Pump 1, looks like Pump 7, looks like Pump 52. If we take that one step further and we go to continuity across the utility, what we have is the ability to reduce the cross-training time. I mentioned that earlier in the presentation. In VTScada, the way we promote that is through the idea of creating templates, as I showed you, and being able to define those templates within one step further, the VTScada OEM layer. So if I look back at our template concept, and I open my template page that I had there, this represents a template of data for a certain site. Okay, if I then take that template and combine it with some other templates that I have for other elements, and I just start creating things that might be used here, there, and everywhere throughout the system, when I'm ready to roll with those things, I can roll them out to a number of different locations. With an OEM layer, what I have the ability to do is to create a set of these functions, a set of these tools. They might be calculations. They could be tag structures that represent a certain, right, I'll bring one up here for you, represent a certain station. So there's a duplexer station, and there's a tag structure for that, as all its faults and its well and such. Okay, all of its information, I can create that within what's called an OEM layer. This OEM layer includes that template. It includes this graphical template. It includes common pages. And then when I want to, I can roll that out to all of my plants. Now what I have is the ability to ensure that all of my plants are using exactly the same set of templates and tools. Moreover, when I make changes to those or add new tools, those are automatically deployed to the entire utility.
So in effect, an OEM layer is an application that you then build your end user application on top of.
Yeah, that's exactly it. It's a VTScada uses a layered approach. So if you have a layer of these tools, or you have a layer of some other functionality, maybe drivers to a specialized proprietary system, then you can include those drivers in yet another layer and make those drivers available to all your plants as well. So this concept of layers gives you the ability to manage the OEM tools with one set of security, and then manage all of your applications with their own individual sets of security.
Speaking of security, that was a hot topic this year.
Yes, it was a very hot topic. It's common topic numero 3. That's numero 3. Balancing IT and operational demands. This was a big one. We had a number of utilities that came discussing issues that they're having from the operational side. They are not happy with the additional demands that IT is imposing. From the IT demands, they're not happy about the feeling that security is almost loose in a way in the operational side. So what we need to do is to look at it from a marrying point of view. How can we make both sides happy?
We met one utility that was actually trying to split off from their IT group because IT didn't understand that they couldn't just shut down all the servers every night to do maintenance. They just couldn't come to a middle ground on that.
No, so we need to come to some understanding of what the priorities of each group are. Speaking of priorities, we've got securing water infrastructure as a Department of National Security priority. They've defined that, so therefore, obviously, there's a lot more focus on the IT security within these systems. And if we look at security management, there's a few initiatives that are underway. We've got interest in migrating SCADA and operational system security paradigms, so bringing the SCADA security up towards the Windows level, being able to manage it as yet another secured element within the network infrastructure. We have SCADA and business integration, and this plays to the first point. If you want to bring enterprise data to the surface and have all of that in one specific location, you have to tie in your networks together. As a result, IT is getting much more involvement in the SCADA networking. And the greatest concern of IT, and Chris is testament to this, is... Because
I'm a disgruntled employee.
That didn't sound right. Is mitigation of potential disgruntled employee risks.
I was doing a roundtable discussion at ACE this year, for four very nice gentlemen, and they all agreed at one point that that was their biggest fear. Was, despite all the sort of cyber threats that they hear about, they were way more afraid of people that they had let go, and so they wanted to know in what way SCADA systems could from one place you could turn off the tap on an employee's access to the system-wide.
So Chris is not a disgruntled employee.
I'm not. I'm very gruntled.
He's very gruntled. Remote access. So if we, over the years we've heard that remote access is being essentially pushed by the SCADA companies as a great new expansion to the system. And yes, it is a great new expansion. However, it hasn't been by the SCADA companies pushing it. It's been by a number of realistic factors. We've got operations have gone mobile. Operators, as Chris mentioned, are no longer sitting in front of a console. They're mobile, they're out in the field, they're doing additional things. They're an effective part of the fire addressing situation. They've got fires out there in the field, they're trying to deal with them. They're gathering data. We no longer have people sitting there. We have quicker problem response, which is expected by the public. It's the I want it and I want it now effect. Okay. In order to address that, people have to have real-time data on them. Culture of connectivity. How many people did we see during the show came to us and said, I have this device. I want to see my SCADA on this device.
Yes.
How do I do that?
And before we fully implemented smartphones and tablets, we would say, well, we're really thinking about it, and they're just walking away. Or they'll grab you by the lapels and say, call me when you do, and they'll walk out. They didn't actually do that. But it was important. If people wanted to use their own devices, it was important to them, and they made it clear to their integrators that that was important.
So they did bring up a couple of concerns that we heard time and time again. From an IT perspective, most SCADA operations teams are unfamiliar with the encryption methods and with other security methods. So leaving that security in the hands of operations feels somehow uncomfortable from the IT perspective. On the other side, operations wants to minimize their interruptions. And we've had clients who have just simply said, we're not connected to the internet. We turned off all of our logins, so we have one single login for everyone. That works for some. It doesn't work for most. So how do we make everyone happy there? What we've done is to address the security within the system by splitting it into two parts. We've got IT managing the authentication process and SCADA admin managing the authorization process. So if we look at that from the two sides, what we have here is assignment of the SCADA users to roles within the Windows security environment. So I'll look at this, show you roles within the security environment. Okay, if we create roles down here, we've got administrator, we've got logged off user, we've got operator. We can make as many different roles as we like. Once we turn on the Windows synchronization of the security system, what we do is we relinquish control of those roles and we push those off to Windows and say, there's your roles. We allow Windows, or the Windows administrator, the IT person, to define who within the SCADA system using their Windows logon becomes associated with each of those roles. That gives them the functionality that they really want to have control over, being able to turn people off. That disgruntled employee, again, not Chris, that disgruntled employee, the ability to say, I've now removed them from all of the software systems across the whole network at the same time they're out. Okay. Alternatively, we have the users here within the system, sorry, not the users, we have the role assignment of privileges by taking privileges here and being able to assign any of those to any particular role. And we can create additional privileges to restrict access to pages, to restrict access to tags, to restrict access to controls, all of those things, internet client connectivity, all kinds of different things, configuration. And we can define new roles. The roles become part of the Windows. Now the authentication goes to the Windows IT people. And what we have also is the ability to have card readers supported for logins. So we've now addressed the ability of people, or the problems associated with having all of those accounts. We don't have to worry about the idea of people being concerned about that, because they walk up with their card reader, they swipe it, they're in, let's go. Reduces the operational burden.
Any other questions about security before we move on? Ding, 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 ding. Anyway, you can carry on.
I'll carry on. Okay, topic number 4, scalability. So as I mentioned, there are a number of utilities who came with interest about multiple plants. Now we have to be reasonable. It is Southern California. There are a lot of large utilities. A lot of people from surrounding states as well who had larger utilities, at least larger from the point of at least 2 plants, a plant and a telemetry system, something of that effect. So they're worried about the ability to start with something and then being able to scale it up relatively quickly. If we look back at the standardization concept, then we can obviously leverage that moving ahead. If we look back at the idea of open architecture, now we can leverage that moving ahead. So our good planning up front has really helped us move ahead with our scalable architecture. Let's look at some requirements at the single plant or telemetry level. Adding new instrumentation, simple functionality. Adding new package processes, not so simple. Adding the remote stations to it. Okay, maybe that remote station is a lift station system or a booster pump or something. And then implementing redundancy. Requirements at the utility level, step higher. Migrating the additional plants and telemetry system to the same SCADA platform. So we want to do that. We leverage our scalability again, or standardization again, I should say. Utility-wide reporting. This is very common. We used to end up with a lot of utilities who were interested in just reporting at the plant level. Now we have utility-wide reporting, and that's starting to move us into the next level, which is to integrate enterprise-level systems, planning, billing software. And from that planning and billing software, we have a number of centralized data stores. This is interesting because a lot of people are interested in this. They bring it up and they say, I'd love to do this. I see real potential in taking my data from SCADA, my data from my AMI system, my data from my CMMS system. I want to bring those all together, make this one holistic approach to the entire utility. Unfortunately, adoption has been really slow with that. Management is typically unsure of exactly what they want to get. And as a result, there's so much data to be passed around from system to system. The importance is to define the reality of it. What data makes sense to pass? So we just got to slow down a bit, look at the value we're going to get out of this, and define a starting point. We can always get to the finish in the end, but we do have to define a starting point to get going. So we've some requirements here. Early problem recognition and improved reaction is what we're trying to accomplish out of these combo systems, or these big data, centralized data systems. Seamless integration of operations and maintenance. Again, think back to the very first slide, the efficiency. It's all about efficiency, minimizing non-revenue water. Major topic of conversation, specifically in California and the southern states. Data sources commonly available. We got a lot of this data available in a lot of utilities. External data, weather, information such as that that's being brought in. Geographical information systems. The most important one to most right now is the advanced metering infrastructure. We're doing this tie-in with a couple of utilities in the Alabama area, and they're implementing VTScada because of its capability to integrate with their advanced metering systems. Their advanced metering now gives them the billables. It tells them how much water was actually delivered and priced. From the SCADA side, we know how much was pumped. If we look at those, we can come out with a general idea of where our problems may exist, depending on how much instrumentation we have throughout the system.
This show, perhaps more than any other, but this has been a common theme of companies, of these kinds of companies that want to start sharing data. This is a conversation that we keep having more and more, but it actually hasn't. It seems to be at the very beginning stages. It seems like in the next few years that's really going to be a thing, sharing SCADA data with those kinds of systems. Reporting, it seems like everybody's all over reporting.
Yeah, I think reporting has really been driven by needs for regulatory generation, basic reporting such as that. We have reports right now that would give you information. Go to our reports. If you look at the reports, some typical things you might want to get out of your reports: daily snapshot information. You've got driver communication errors. This is a very common one here, this pump discrepancy report. This gives you the ability to, and it almost starts to get towards the enterprise level, whereby it's telling you these are the pumps that have had different pumping rates or different amounts of time pumping during the night, different starts and stops, different pumping rates, and they can give that data off to the utility to the maintenance group for them to do the analysis, and they know exactly where to focus their attention for the next day. Okay, so what we're looking at now is the next step whereby utilities are able to say, I've got this computerized maintenance management program, I've got this SCADA program, let's marry the two and auto-generate the work orders associated with those systems. Now, this is not, we're not creating the wheel here. A lot of places have done this before, but they tend to be large budget groups. What we're seeing now is a move from the large budget group to relatively small budget utilities. Keep in mind that obviously the amount of data that has to transfer between system to system is significantly less. But if we look at standards such as ODBC, OPC, SOAP, these are all common intercommunication standards from software to software. So as long as you have that kind of support, you can continue on and do those kind of things.
Plus, many of these services are now cloud-based, which just makes it so much easier.
Yes, that's true. Yeah. A fine example would be Halifax Water, actually our local utility here. They have 14 VTScada systems right now, I believe. And of those 14 systems, they're all driving their data into or at least a number of them are driving their data into an OSI Pi central historian, very large utilities historian, and from there they combine lab information data and other information data to do things like leak detection. They're leading the industry in some of these things. If you have any questions, you can always ask those guys. I can't tell you the details of that. Topic number 5, sustainability. Where do we go from here? So how do we ensure that from this point on, our system can be maintained? This is an interesting point and was constantly iterated to us, constantly repeated to us every time we saw a new utility arrive at the booth. They want the power to configure their SCADA software internally to make minor changes. They want to rely on integrators for major enhancements. And it's again the idea of I want it now, I want it now, give it to me now. Everyone wants whatever they want, and they want it immediately. So how utilities see it, they see it as a sign of self-sufficiency. And there's a reason for that, and I'll show you that in the next slide. In particular, other than just self-sufficiency. They want ease of use tools for basic tag and graphic changes. So if I'm developing an application here, and this is my operational view, and I want to add something new in, I want to be able to just go to that screen and grab a new piece of equipment, take a pump, and grab that pump and put it on the screen. That's how I want to be able to function with my system. I want to be able to add in a new dial. I go to my gauges and I drop in a new dial on the screen, and I'm done. So when I roll that out, bam, it's rolled out across my entire industry, not my entire industry, it's rolled out across my entire utility to all of the SCADA nodes that are utilizing that page.
That looks great.
Yeah, it's kind of awful, isn't it?
So as Natasha just texted me, she's our back channel feedback person, we are getting close to time, so.
Yep. 2:45, is that right?
Yes.
Okay.
Yep.
All right, so with responsiveness, not just responsiveness for them being able to do their own changes, but they want remote support, which is preferred over on-site support. I heard a lot of people say, I just want to be able to call somebody, have them log on to my system and be able to help me make changes, be able to help me understand what's going on, make those minor integration changes if they need be. And how integrators see it. They also want the remote support options. They want a really well-defined methodology for being able to implement change remotely, minor change remotely, and then being able to go to site to do travel to site for the major changes. Okay.
I'm writing an article right now about an installation, or I wrote an article a few weeks ago about an installation in New Brunswick, and it literally wasn't safe for the integrator to get to them throughout the year. But now, as it stands, they almost never have to go to site for SCADA software. They only go to site for software or for hardware.
And I want to touch on this item here, the out of business problem. This was an interesting thing that came up. I say some large California utilities, talking very large California utilities, facing a relatively unique problem. It's unique to them because they have put so much energy and time into developing their utilities SCADA system that the idea of change is monumental, or the amount of time that they feel they have to put into this is monumental. They've got software vendors that are either very small or have gone out of business. It seems to be somewhat of a dichotomy. A very large utility, very small vendor, or not supported. Think of the situation. They were early adopters. They wanted to utilize SCADA when it first came out for the water wastewater industry. Not first came out maybe, but we're well early in the adoption stage. They implemented some functionality. They grew over time. They added in more and more. But in order to maintain some standardization, they created limits around what they would accept. As a result, they bought more and more of the same. Technology, later abandoned by the manufacturer. Just simply network market conditions, maybe the certain vendors didn't exist after a certain period of time or couldn't survive. Change is now seen as either too expensive or too disruptive to continuing on the daily activities. So what you really need to do is to consider a product and a solution that has been around for a while. New entrants, this industry has lots of them. They also have a lot of new exiters. Okay. Companies come, companies go. Right now we've gone through an evolutionary phase or not an evolutionary phase, but almost a cleansing phase, whereby during the 2008 time you saw a lot of vendors maybe disappear. We've been in business for 28 years developing and supporting a single evolving SCADA software platform. And we have what's deemed to be some of the best technical support in the industry. The version upgrades are a key point to this. For these utilities, they don't have the capability to support the version upgrades. In fact, one of the utilities I heard about, they've gone to court to buy the ownership rights to the software that they have installed right now. The reason is that they don't have any other mechanism to support it. So now they're in twice as much pain. Not only do they have this software that's installed in places that they're having a hard time migrating away from, but they also have to maintain that software platform themselves because there's no one else out there to do it for them. So the benefits to buying something that's reliable and been around a while is that you have responsive, reliable support in the short term, but in the long term you can at least have confidence that the future continuity of upgrades and service will be there. lessons learned. This is what sums it all up here. This is what we learned from ACE in a nutshell. The industry is trending towards efficiency. I think we all knew that. This really did hammer it home, more so in California because everyone's all about efficient everything at the moment. Efficient power use, efficient water use, reducing the waste of water generated. Secondary, good upfront planning creates a scalable platform. I think we've got that feeling from looking at all these different situations. We need to balance our culture of security, our IT security, and our operational effective. Can't fight, we can't get divorced. We have to work together in order to solve the problem. Our software system interconnectivity is upon us. Okay, so it's not happening a great amount yet, but it will. It will come very quickly, and Chris and I have seen it. We all saw it at the booth. Everybody's interested. Most don't know where to go with it yet. So we had a good conversation we can open up to and have a lot of chats. Integration roles are currently changing. Utilities are interested in self-sustainability. In particular, when you look at California, you can see why. California is not alone in that, I'm sure. There are other places that are facing the same. Customers realizing the value of long-term supportability. Okay, they're starting to realize that over the low cost of getting in. It's the cost of ownership that's starting to make a much greater effect on them. Okay.
Great.
So that's all I have for now. Chris, you got
That's
any?
great. No, I think that's it. Thank you, everyone. Just a reminder, the PowerPoint plus a link to this recorded webinar will be posted to the events section of our website within the next few hours. It takes a little while for the video to render and then upload to the web server. And then you can actually watch it again, or you can send that link to your customers or to the rest of your team as you see fit. Anything else? We've still got a few minutes. If anyone wants to stay on the line for a little longer and type in some questions, we're happy to answer them. I did forget, Mark also wanted to let us know that he works primarily in oil and gas, and he's more and more, his clients are adopting the ASM guidelines for HMI display.
Ah, interesting.
Maybe you want to explain that, ASM.
Well, maybe what we can do is, it's probably best if we have Mark tell us what that means, and we provide that as far as information out to the whole group.
Sounds good.
What I'm thinking is, why don't you throw our phone number in there, and anybody who wants to give us a call now, if they have any questions that they didn't want to ask here, they can feel free to give us a call. We're going to be around for a couple of minutes once we turn off this webinar. If you'd like to have a chat, all lines are open right now. Thanks very much for your time.
Thanks, everybody.
Thank you very much. Take care. Chris, did you want to fill that number in, and then we'll shut it down?
Yes. 1-800-463.
463, give us your credit card. Just joking. You can just put in the main number.
Great. That's our 1-800 number. Give us a call.
Thanks very much, everyone.